Okay, so the first thing we try to understand in R is the basic data types. So, as any programming language, okay, it supports specific data types, and that is, I think, the core fundamental on which the other things are dependent. Now, typically, when we say about R support five basic types: the character, numeric, integer, complex, and logical. Now let's jump into system and let's start creating all these different types. So the first variable I create is of type character. Now we have seen how we can create a variable. So to create a character type variable, you have to put whatever thing that you wanted to create as a character into the single quote or double quote. It doesn't matter whether you put it in single quote or double quote. R will define it as a character. Okay, so this is the first. Okay, so now you see here. Okay, it has automatically converted uh, into double quote. So you can define it as okay as a number. Okay, but now even it is a number, it is treated as a character because you have put it into the double quote. It doesn't matter, in fact, even if you put it in single quote, it would be still the same thing. Okay, so now we defined a variable of the type character. Now how do we find out whether what is this variable and what type it is? One thing is that if you are using RStudio, you can immediately find out from here. Okay, but there is a function that can be used. So there is a function called as type of. Okay, and let's see what is the type of this. It's a character. Okay. Uh, Now, one thing before we proceed ahead, okay, that all the objects that you create in R, okay, it is treated as a object. So any variable or whatever thing you create, okay, are treated as an object. And if you have learned or know about any object-oriented language, okay, so object is a one which has some properties or maybe the attributes, and the type is a one of the attribute that exists, and we are actually check this using this type of function. So if you see this type of definition, it determines the what is the internal format that particular variable is storing. Now there is another interesting function that I wanted to introduce, is called as a class. Okay, it is from the base package. Okay, and it also defines what is class. The objects belong to the which type of class, and in this case it would be a character. Okay, now let's move ahead. Okay, and now I will create a numeric type of variable. So let me create another variable. Now I stored the value as 3.0. Okay, and let's see what is the class. Okay, so class for this is numeric. Okay, and let's see what is the type of, and your variable, it's double. Okay, perfect. Now you have seen that I have stored the value as 3.0. Okay, it is shown as 3 here, and let's try to just save a integer. So I try to save integer 2 into variable f. Okay, you can see here, and then now let's find out what is the class again. T, numeric, and let's see what is the type. Now see here, I am just put number as 2, okay, without any decimal place, but still when it, when we try to see the type, okay, it says double. This is because internally this value is always stored as a double. So any numeric value that you are trying to save, if you don't explicitly denote it as an integer, okay, then it would be stored as a double into the R. Okay. Now how you will explicitly create an integer type of variable? So let's create another variable I. Now I wanted to make it as a uh, uh, as a integer type of variable. So what I will have to do is I have to just put a capital L next to it. Okay, now if I create it, okay, the value is stored as 4L. Okay, but see, it's not a character. Okay, there is no double quote stored with it. And let's see what is the type. So how internally R has stored this value? Okay, see here, it's integer. Okay, so remember this thing, that explicitly whenever you want to define any variable as an integer type, you have to always put this special character L next to it. Okay, and now let's see what is the class. Okay, okay, it's integer. So I hope it is clear to you. Okay, because whenever we try to store any value, okay, without any specifying the L, whether you give dot next to it, decimal place, even if there is no decimal place in the value, still R will store it as a double. Okay, now we have seen the character type, numeric. We have seen now the integer. Now there is a special type called as a complex. Now let's try to create a complex type of variable. Okay, so I'm just creating the complex type of object, and here I will just put it as a I. Okay, to mark, to store it as a special type of value. So here you can see. Okay, and let's try to see what is the type. So it's complex. Same way if I try to use the gym class, it's a complex. Okay, and now the time is for the last type that would be very widely used, is called as a logical, which actually stores a value like true and false. So here I will create another variable. Okay, and now I wanted to make it as a logical type with value as true. Now see here, I'm writing it as true but without any quote. Okay, so no single quote, no double quote. If you define it in single or double quote, R will store the value as a character type. Okay, so now it has been created a variable of the type logical. Let's see, logical. Okay, and similarly, if you want to create logical variable with the value false, okay, then you just say for false, and then it will be created as a type um, logical. So let's see. Now there is a shortcut that are defined for creating the logical type of variable. So instead of writing this complete true or false, if you just create a new variable, okay, and just said it as G, that means it is a type of true. So here you can see true. And if I create another variable, with just F, okay, that would be automatically treated as a false. Okay, so these are the basic types that we have seen. Now let's jump back to the next topic. Now we have seen what are the basic types. Now there are some special numbers, or you can say objects, that are there in the R. Okay, so the one is infinite. Okay, so R can store an infinite value inside this. So what is the infinite? So if you try to divide 1 by 0, okay, mathematically that value is equal to infinite. And if you try to divide 1 by infinite, the value is 0. Okay, so it's a maths, but R allows you to store this value, which is I guess most of the programming languages are not supported. Okay, then there is the another thing is nan. Okay, that is actually full formed as not a number. Okay, so whenever you are trying to save any number into any particular variable, but you don't want to store any specific value, so you can store it as a not a value or not a number, but it's a type is as a numeric. And then there is something called as nothing. Okay, so if you want to store nothing into character or into the logical variable, you can use the na. So let's see, let's jump back to our RStudio. Now I think it is little glittery, so I will just clean it off. You can use this button, clear console, to just clean it out, or you can just press Ctrl L, and whatever there, it would be clean out. Same way I will just clean out all the variables. Okay, now how we can do it using the coding, that we will see in next video. But now I want a clean session, so let's start. Now we will create we will see what will be the output. As I told you, let's try to divide 1 by 0. Okay, and you can see the output as infinite, and you can store it, this value. So I create a variable type I, and I'm just storing the infinite as a value into this variable I. And now let's try dividing 1 by infinite. So I am dividing 1 divided by I variable, which actually holding the value as infinite, and the result is 0. Okay, as expected. Now let's try to store as a numeric value. So, but I don't want to store any value as such, so I can define it as a nan. Okay. Now you can see here it's created, and let's see what is the type. Okay, so type of J. Okay, and it's double. So R is treating this J as a numeric type. Okay, and it's very important to understand these things, because whenever you are storing a value, okay, you won't store it as a na, that we will see now. Okay, but you have to store it as a nan. Okay, not a number. Now the next thing is, we have seen these special numeric types. Okay, this infinite and nan. Now how about if you want to store a missing value? So nan is actually similar to a missing value, but for a numeric type of object. But how about something where you have defined it as a character type, or a in a logical type? So that you can do. Okay, so I create another variable, let's say f. Okay, and you can store this type of value using na. Okay, so by default, okay, whenever you stored if you just stored something, okay, it is assumed that it is a type of logical. So let's see what's type is written. See here, it's defined as a logical. But let's say I create another variable of different characteristic value. So I think we have discussed about this C function, and now I'm just trying to save some value into this a b okay, and then I don't, there is nothing, I want to store nothing, and then D. Okay, so I am storing four values. Okay, the first value is A, second is B, third is nothing, and fourth is D. So if I just see, it is defined as a character type. You can just see this, see here, type of, and type it C, and its character types. But here you can see, the A, B, and D, they are in double quote, but whereas this value NA, okay, that means nothing, okay, or missing value, okay, and that is indicated by NA. So these are the some special types, okay, that you should understand. Now let's see what is the next topic. It's the type functions. Okay, now we have seen the first two functions, the type of and the class. Okay, that can help you to retrieve what is a particular type of that variable or the object. And then there are two interesting functions, one is and the second is as. Okay, so now when is used and when is as used. Okay, so whenever you are doing some checking, okay, if you want to see if particular variable is of what type, whether it is a numeric or whether it is a character, you can use the function as is. So here let's say I wanted to check is, okay, and then I wanted to see if my variable c, is it a type complex. So I can say is dot complex and c. Now it's false. Okay, now let's see if c is a double. Okay, so whether it's numeric type double. So let's see, say no, false. And now let's see is a character. Now my batteries are draining, so it's time to close down. Okay, time to see. It's true. Okay, so it is of type true. And then there is a functions which is called as a as. Okay, so now whenever you want to convert something into the number or character type, you can use the as function. So let's see, I will store a value 5 into the variable j. Okay, and now let's see what is its type. We will use the is function is character. Okay, and I am using the j. Okay, it's false. Now I want to convert it. Okay, so what I can do is, I can use the function as, and I will call it as character. Okay, so now whatever input that I will be giving, okay, to this function, okay, it will be converted as a character type. So if I put it as uh, once again the j, so now you understand j is numeric type. Okay, and now if we just run it once again, is character. Okay, and now it's true. So these are the basic types. Okay, and I have explained the basic functions that you can use to determine and then how we can convert the objects. So see you in next session then.